I want to welcome everybody again to the new, improved, and at least different series of the spring semester covering environments seminar series. And it's going to be a little different because we're going to have two speakers every last Friday of the month during the spring semester. And today we're leading off with our leader who needs no introduction. Good.
Thank you, sir. Thank you. Thank you. All right. Yes, I think my name is Gene. Gene, yeah. GIacomelli. GIacomelli. Thank you for coming today. Appreciate it. Yes, we're doing a doubleheader in baseball lingo. So I'll try to save a little time for the second speaker, and I'm just going to get started right away. Controlled Environment Ag Center. Let's see what's going on in Arizona and beyond. Second line is underlined. We're training students who will raise food on Mars. How's that for some futuristic thinking, right? And of course, we're part of the College of Agriculture and Life Sciences, the College of Engineering. I'm in the Agriculture and Biosystems Engineering Department. We have other engineers here as well, and we have those plant scientists in School of Plant Sciences. Dean Berger says we should prepare our students for jobs that do not yet exist. I think the Mars job is going to be out there a little bit, but in between, we need to grow on Earth today, and that's our goals is to develop the skills and give the students the opportunities to develop technology so that we can grow more food, feed more people. And this has to evolve, will evolve from controlled environment agriculture, not only from growing in the open field. And I'll get to that in a second. These technologies are different. They're more controlled. The students need education, experience, to develop their expertise. But let's take a step back. Field production agriculture. It's certainly what we've created is the most productive, inexpensive food production system the world has ever seen. Through breeding, through improving nutrition, more efficient water use, and automation and mechanization practices to make it easier to do. In recent years, so-called precision agriculture has entered the scene, which creates information for the grower to make better, more informed decisions. In doing so, you could look at this picture. It's a top view of a field, open field agriculture, a wet soil and a dry soil, and they can see two different leaf temperatures, 30 degrees C in the wet soil, 41 in the dry, and get information about the crops and their effect, their stress, or their growth, and ultimately develop water savings, nutrient savings, pesticide, herbicide reduction, and improve labor efficiency by making the crops more precisely produced, if you will. However, agriculture and precision agriculture are limited in what they can do in terms of controlling based on the information that they get. Here is your typical Iowa cornfield in the middle of the summer. You get information about how those plants are grown. They all look pretty good to me, but the computer can tell differences, I'm sure. But then I ask you, what can you do about it in this circumstance? Nothing until next year. You stand there and you sweat. It's about all you can do at this point in time. Now, if we look at controlled precision agriculture in a controlled environment, we see not the same, but similar corn being grown in a greenhouse out back. Any day of the year, this greenhouse could produce this crop. Unfortunately, these paper bags appear on top of the ears of corn, and they're working on that, though. Breeding will get rid of those bags, and we'll have ears like this. This is A.J. Jones, who's working with us, developing this program, proof of concept as he calls it, developing the needs for fertilization, growing media, light requirements, air temperatures to produce the quality corn that you see in this picture. What I show off to the side of the picture is that it's in an automated greenhouse. And this is for seed corn production, not for eating at this point in time. They're on transportable benches to improve labor efficiency. The benches are ebb and flood irrigated to recycle the water and the nutrients. Fertigation is used to provide the right mix of the nutrients formulation, and it's in a climate control. So you can use controlled environments to predict and achieve more crops per year, obviously, than you can in the Iowa cornfield. More complete crops with less loss in this controlled environment. And their expectation is that this is a cost-effective thing to do in the breeding business. Not to grow corn or replace what's being out in the open field, but for this type of work. Let's come back to what we're more accustomed to, this head of lettuce. And the expectation of hydroponics for safe foods, safe, secure foods is key, and that they are healthy, they're locally grown, they can be produced organically, and we'll hear more about that later, and that it's a growth industry, no pun intended. The Arizona farm statistics, I'm not going to go through these except to say this. Greenhouses with vegetables and herbs being grown are excessively being increased compared to other crops, cotton, lettuce, and that the value is in excess of a yearly $1 billion in 2015. And that if we look at the bottom of that, there are, as of 2012, 108 greenhouses for vegetable crops in Arizona alone, and 55 of them claim to grow tomatoes. So you get a little bit of perspective of Arizona. Now, the rest of the country, for the large growers, are shown here, many in California, Nevada, Utah, Arizona, Texas. Also out in Maine, more recently in Ohio, and in Michigan as well. These are the larger growers. The smaller growers are dispersed throughout the country, and those numbers are increasing at a greater rate than the large growers at this point. Example in town here in Tucson, Merchants Gardens. Chaz Shelton and Bill Shriver are co-owners, co-founders of this facility that produces green crops, healthy foods. Only 2 years in production. They are using hydroponics and will be using aquaponics in the near future to grow their crops. They're located in a deserted school, a school that was shut down, that can then be close to town to provide the crops to the school system as well as to other outlets as well. And we'll hear that James Ebeling, our designated campus colleague for the center here at the university, has been instrumental in helping them get in operation, as well as Giovanna as well, right? Healthy. How did they do it? Or what system did they use? The floating raft. So here you see the lettuce and the root system once the floating raft is lifted up, the beautiful white roots, the water underneath. And in this case, we were doing some studies. Miles Lewis was working with us to do some dissolved oxygen studies in our greenhouse. But what we see here in the deep water culture is the fact that the large body of water acts as a buffer for the high temperatures that we get here in Tucson, Arizona, even in the greenhouse that we try to control. Keep it under 85 degrees on a tough day. The lettuce with the roots in 75-degree water temperature will not bolt. It will grow to maturity and good quality. So it's a hydroponic system that conserves all the water and nutrients and makes sense for the semi-arid region, the desert regions of the world. The new world, the pink lights, the pink LED lights, some combination of red and blue LEDs that give us the impression it's pink, in a stacked system, an ebb and flood stack. There's one, there's another at the top, and lights underneath the bottom of each one to light the crops grown below. This is Dr. Murat Kachira's efforts here at the university at the Controlled Environment Ag Center, sustainable CEA systems, and artificially lighted vertical farm, ag farm, as UAG farm as I call it. Some of his work was supported by Paul Hardy of Civic Farms, who's behind it right now. Also Indoor Harvest and Illumitex. Illumitex with lights. Indoor Harvest was the hydroponic system. Grad student postdocs are working on this, and we look forward to seeing much information from a very, very intensive controlled environment system. Taking it a step further, Dr. Joel Coelho in the Ag and Biosystems Engineering is interested in modularizing and simplifying, and he shows a diagram of a modular unit that would use sunlight to grow, and see how that modular unit can be put into a group of modules that would offer sufficient light for growing the plants. This example here, I believe, is called a Sky Farm out of Singapore, and it's a greenhouse, traditional greenhouse, but with a moving trays of hydroponic lettuce that get to share the sun as they move through the day. Mushrooms. Another, as it says here, the fastest growing specialty crop worldwide. Decomposer, something, crop that's doing something a little bit different than what we do with our hydroponic systems. A valuable crop. We look for Dr. Barry Pryor to continue with his work here at the center so that we can develop that more. He has a demonstration just across the way, and he has the commercial facilities that he's doing work in right now, and we hope to build some new ones in the future. If this is strawberries, and this is the Controlled Environment Plant Physiology and Technology Lab, then this must be Dr. GIacomelli. Yes. And here's a description of what her laboratory works on. Horticultural engineering, I love it, and plant physiology. The combination of the two that makes it work to understand the plant and then provide the plant the environment that it needs to grow. Wonderful. Here's some of the projects. Strawberry production, trying to bring off-season strawberry production back to Arizona. Can you imagine having the berries from November through the end of February? Are there a whole series of holidays in there when we would love to have fresh, locally grown strawberries? I think so. It's a good time of the year to do it. A lot of her work also associates with growing the plants in general, LED lighting. She's worked with the mushrooms and has done vegetable grafting as well to try to improve the capabilities of the plant to produce in either in the controlled environment system or in the field production system. I hope this has become analogous to the Mars Lunar Greenhouse, this picture. We have to accentuate that a little bit more, and we show these images from NASA, these posters. We have them in the room too. Why? This brings even more interest to the students coming to utilize controlled environments in a very specialized situation of a cylindrical, collapsible growing system that could someday leave the planet in some form to produce food, in this case to provide bioregenerative life support for the astronauts living and working on another planet. And this continues with Phil Sadler's goals of the success, and Roberto Fafato has now taken the lead on that. I am still associated with it and part of the crop production. And one of the units still remains at Biosphere 2, so that we get the outreach, get it out of the lab in the biosphere to people to see the crops growing in the Mars Lunar greenhouse. I had to put this in there. We're not doing any work with cannabis here on campus. We're not allowed to, or we're strongly discouraged. And federal laws make it less interesting or able to do it. But we recognize that, and not by saying no here, from the standpoint of doing research on it, I'm not making any kind of statement about whether or not you should be a user or not. I hope you realize that. Essentially, this is another plant being grown. And there is a lot of people trying to learn how to do it better, and putting it into more improved controlled environments will improve the quality and the capabilities of that product. And ultimately, as the price begins to drop, as production increases with more and more states getting into the business, that there will be a need to improve capabilities that way. Okay, our supporters. I'm going to show you 2 pages here, and I'm going to explain why they're here. One of the primary movers was the NGMA, who suggested that we should do a campaign, a letter writing campaign, and see who our friends are, who out there would support us, and prepare this. And we ended up with 60+ companies from around the country and from around the world, for that matter, that created these letters. From that, Austin put together a booklet that's online, and actually these logos and these company names are online as well. These are the Arizona companies associated with controlled environments, and the across the U.S. national companies that associated with controlled environments and all aspects of that, and some international companies and educational institutions. From these letters has come and developed a concept for CEA Leadership Forum. This will occur on April the 6th. It's at the end of our short course this year. Short course is the 3rd of April to the 7th of April. And I said the 6th, didn't I? April the 7th is the forum. And what that will be is there will be invited speakers from within this group of supporters and others who will be with us for that morning to follow up on discussions from a questionnaire we created. 19 people responded out of 38 requests for information about the importance they believe of controlled environments and how it relates to production agriculture and the future. And these will be put together, ultimately leading to an advisory board for the CEAC, for the Controlled Environment Agriculture Center, and obviously to future opportunities for research, development, and teaching. This will occur at the University of Marriott. Our short course this year will move out of the off-campus resort hotels and will be the University Park Marriott, very nearby campus. Some of the invited speakers that we are in the process are described here, from entrepreneurs to university people to managers of large greenhouses and small greenhouses, seed companies, urban agriculture crops producer, the leaders in climate control in greenhouses and in buildings as well, NASA scientists. So it will be a diverse group of people that will bring us to some additional consensus about the future opportunities in controlled environment at the Controlled Environment Agriculture Center. A lively picture of the young people in the plant science class in formerly Dr. Pat Rohrbaugh's greenhouse, now Dr. Stacy Tollefson. This was her first class, 35 students they're not so early on. Those plants are a few months into production. They still seem very happy, Stacy, so way to go. Keep going. This is the classroom. This is the hands-on part of this educational experience that we offer here. We're sitting in the classroom part of it, but out there is where they can get that experience at an introductory level and then again at an advanced level. And they must produce. They are graded on the quality of their efforts. Workshop. This is Miles Lewis making a presentation at a recent workshop. He's with the Arizona Vegetable Company, and he's describing the floating raft deep-water hydroponics system and its benefits in the arid regions of the Southwest. Normally we have done one of these a year. We're changing that to do it 4 times a year and use it as a revenue-generating procedure to support his salary. Miles will still be part-time, but he'll be here to give the short course, the workshops, as well as work with some of the students, because these are all student-grown lettuces with Miles as the overlord or watching over them in their efforts. In addition, of course, we have the tomato workshop, which Dr. Tollefson, Stacy, completed for the first time all by herself this time. She has had support from Dr. Rorba and the students during the hands-on part of it, which is a good deal. And we're considering actually increasing that to a second one, maybe later in the spring, early summer. All of this to get more exposure, to get more growers out there with experience. There's 3 tenured faculty at the CEAC, soon to be only 2. Dr. Cherry Kubota has a great opportunity to go to Ohio State University and supplement, increase, improve, develop their controlled environment education program. And we wish her the best to do that, in doing that, and we wish that many students will come out of that, because we need a lot of students in the industry with experience that we know that Cherry can help provide. At the moment, there's 7 full semester courses that are taught by our group, and there are other departments: soil, water, environmental science, agricultural tech management, biosystems engineering, and plant sciences, that have right now about 57 students waiting for these courses that we teach, the fundamental courses. And we've increased enrollment this year in the intro course. And there's a discussion about converting the intro course into 3 credits in the classroom that could then go online and teach students much more efficiently, bringing more numbers, and have a 1-credit laboratory, and make that optional. We would strongly encourage it. Have them come onto campus, particularly if they're doing it online, to get some experience. These are something that we're looking into, and as well the 2+2, the bottom line there, the community colleges, 2 years of study there, come here and finish off 2 more years to get their 4-year degree and gain the experience that we could offer at the center. I think I'll hold off on the facts here, but basically the numbers are distributed in biosystems, plant sciences, soil, water, environmental science. Most are in plant sciences that come to our program. Right now, I can count about 87 active students, alive and well and flourishing in our program. How are we paying for all this? The estimated income that comes in from research is on the order of $600,000 a year for the 3 of us combined, Sherry, Morant, and myself. And our goal was $500,000, so we've met that. And in the next years to come, we're looking to increase that to $1 million a year. You realize that that money is needed to fund students, to support the research that is done, and to support the infrastructure of the university itself. One thing we'd like to do and have opportunity is to create high-tech greenhouse facilities both on and off campus. Civic Farms is working with us right now in the multi-level indoor pink-lighted studies right now on campus. Hungry Planets is in the process of developing a public-private partnership to develop a educational greenhouse, but a production greenhouse downtown on a rooftop in Tucson. We want to look to new funding programs, particularly for automation and mechanization. Once the lighting challenge is solved, the high cost of electricity for growing crops indoors using artificial light, the next big cost is labor. So we need to look to mechanization along that line. And here's a picture Murat created that gives us some idea of how this new greenhouse might look and fit. It's a tall one. By the way, we're sitting in this building up in the corner here. And there's the teaching greenhouse, there's the two Polytex greenhouses, and there's the high tunnels. And this is the new facility complex with greenhouses, growth chambers, and more, all in one unit. In concluding impacts of our faculty, staff, and DCC, the campus colleagues, the campus colleagues and our students all contribute to many of these at some level that you see listed here in agricultural production systems, outreach to the public, and look at the last line, social and educational programs. Austin and Aaron, they've been on board just a few months now to help get our information out more readily through social media and through efforts like this. Rafi is a designated campus colleague himself who did not introduce me, but we'll fix that next time. No problem. He runs this event. He makes it work for us. So we're really encouraged by all the interest that's out there about what we do, and so certainly we're interested in about the research we do. So we are driven by the future, and we are encouraged by the past. We feel that our 16 years here has put a mark on the planet about Controlled Environment Agriculture Center, and that we are a go-to place. People come to see us, to talk to us, to work here, to study here. But in part, it's because of 40 years of previous experience at the Environmental Research Laboratory that was here at the University of Arizona. So there's something to be said about continuity. There's something to be said about bringing people together and continuing on into the future. The controlled environment is going to be certainly key to that. Next. Future impacts. Automation and mechanization for precision agriculture in controlled environments. That's what I was saying about a new faculty member, potential new faculty member. New technologies, greenhouse pharmacy. We had Dr. Andrew Weil here a few weeks ago, and we talked about how to grow crops for pharmaceuticals, nutraceuticals. Organic controlled environment, won't say anything about that. That's Stacy's going to just beginning that program, and away we go. And then data science for improving our understanding of the complex growing system inside the complex greenhouse. And then you see a lot of white space. That's for the other new ideas that are to come, in part because of that event on April the 7th. And finally, greenhouse production systems for people, from rooftops to high tunnels, from closed systems to open gardens, from Earth to interplanetary space. Wherever you go, the focus has to remain on the plant biology. So bring that biology, add a little engineering, and controlled environments for plant production will develop and help solve our problems that we have. I know I've been hearing this a lot about extraordinary times. This picture was created about 5 or 6 years ago when there were some other extraordinary times. And I say that extraordinary times require extraordinary steps. It's time for us to move forward, and that's our plan. So we hope at some point see you in Tucson, Arizona. With that, I'll say thank you very much, and I hope there's some time for Stacy to have her presentation.